Hello and welcome. Today we will fully rebuild this 2.8 liter for my E46 and we're going to start right away because there's a lot to do. If you're going to buy new piston rings, it will be really easy because there's instructions with the piston rings, but if you're going to reuse the old ones like I do, you have to clean them really thoroughly and then you have to make sure to put them in the same position as you're taking them out with, and you have to respect the orientation of the ring because you can't install a ring upside down because some of them have grooves that need to go in a specific way and you just need to install it just how you're taking it off. So I'm just gonna do that right now. Before we can install the piston into the engine, we're gonna insert the top part of the rod bearing. To do that, we need to clean all the oil from the contact surface where the bearing meets the actual rod. There shouldn't be any oil because that increases the chance of the rod actually spinning, and there is a special zinc coating on the actual bearings themselves so that the rod doesn't rust right there. Before putting the piston in our piston compressor, I'm going to use liberal amounts of oil to make sure that I don't scratch anything and the piston can slide in freely. As you can see, I've already done all 5 other pistons. Another thing I forgot to mention is we need to respect the arrow on top of the piston. The arrow points towards the front of the engine and that's the way we need to install the piston. I'm also going to use a lot of oil in the cylinder bores. Still have to compress the piston rings. Now that the piston is sitting in the correct position, we have to make sure that the compressor is sitting on the block, because otherwise the ring can slide out and actually break it while we try to push it in. So I'm just going to use a hammer to lightly tap it into place. And now just a push with a rubber mallet or the rubber part of a hammer. Piston's installed. Now I'm going to push it down onto the crank. I made sure the crank is sitting at the bottom center so I can just push it down straight and it's going to land on the crank. Like so. I have put some plastic gauge right on here and now I'm going to torque it down with the old bolts. I've got some new bolts. These are stretch bolts and need to be replaced after every single use. And then we're going to do the original torque procedure, which should be 5 Newton meters application torque, 20 Newton meters jointing torque and then 70 degrees torque angle. Now our 5 Newton application torque, then 20 Newton meter jointing torque, some new rod bolts, now that the rotating assembly is back together, we can continue with the chain drive. First, the main sprocket with the oil pump chain in position. I'm not going to do the oil pump chain tensioner mod from the S54 engine. That will come in a later engine build, but not this one. This is just to get the car back on the road. Our new chain guides. And now the tensioner side. A new chain. As you can see, when we compare the old with the new, there's no chain stretch noticeable, but we're still gonna install the new chain. Now we're ready to put the timing case back on. Before installing our timing cover, we're just quickly gonna renew the front main seal. Just gonna tap that into place with a hammer. Now that this sits flush, we can install the timing case. I'm also applying a very thin layer of silicone so that it doesn't leak, both coolant and oil. I always try to put bolts in so that the gasket is aligned correctly, and then I just drive everything into place with the actual screw, tightening them slowly and moving across the timing case. The last 2 bolts for the timing case go in here, and these will be installed later on when we put on the head. And I'm just going to check, but I can't see any silicone protruding through, so we didn't put too much on. Great. I've also cleaned the oil pump in the ultrasonic cleaner, Unfortunately not completely, but my ultrasonic cleaner is kind of small. I actually bought that really cheap, and yeah, it's been great since, so I'll probably upgrade to a bigger unit in the future. I just chucked the whole piece in there, so now we need to disassemble it to make sure that there's no water left in there. I'm actually a bit stupid because right here there's a circlip that you need to remove to gain access to the spring that controls the pressure, as far as I understand this oil pump correctly. And yeah, I don't have any circlip pliers, so I can't remove it. I'm just going to blow it out with compressed air and spray a lot of oil in there so that it doesn't rust. Since this engine is going to get transplanted into the car relatively quick, I think we'll be fine. If we get a no air pressure light, then that's another thing. But yeah, I think it's going to go fine. If I remember correctly, there's going to be a place on the pump where there's going to be two markings, which direction they go on. Yes, there's a dimple, and on the other side of the rotor there's also a dimple. These need to go back into the same position, into the housing. There's scratches pretty much everywhere, but none I can get over it with the fingernail, so we should be able to reuse this pump without issues. These pumps are not known for issues. I think it's because they're really sturdy, because their design is just so simplistic. Even here, absolutely nothing that seems too worn to be reused. So just gonna put some fresh oil in, blow it out, and then it's ready to be reused. Now I'm going to put the head back onto the engine, but first I need to make sure that all the mating surfaces are properly degreased, and yeah, I'm just going to do that really thoroughly right now, both on the block and head. Our new shiny multi-layer steel head gasket. Before I'm going to put on the head gasket, I'm going to put a bit of gasket maker on the mating surfaces from the block and the timing case. Just a tiny dab, and then take off a bit of the excess, like so. Now I'm going to put the head gasket back on, like so. And now the head. Managed to get the head on with some help. Now we're going to install the head bolts. The new ones, despite being from L-ring, unfortunately came without the washers, so I have to reuse the old ones. Not ideal, but not gonna damage anything, I hope. I've cleaned the thread holes really thoroughly, and now I'm gonna put a bit of, now I'm gonna put a bit of spray-on oil on them, and then we shouldn't have any issues. I'm actually going to start with 10 Newton meters to make sure that the head is sitting flush and the pressure on it is even, so that the head gasket is seating correctly, and then we're going to start with the actual torquing. Now we're going to start torquing down our new head bolts with the correct spec. Specs for this engine are 40 Newton meters, then 90 degrees and 90 degrees again. In case you've been a long time subscriber, this is a lot easier than on our M51 powered E34, where the torque specs were just insane. And now our first torque angle. This is even more stressful than on the E34, just because I know that these blocks are so prone to ripping out the threads. Makes me so anxious, to be honest. Well, it did survive the first round of 90 degrees. I've marked every bolt, so every bolt is done. Now I'm going to wait before I do the second round. I want to let it settle, and yeah, I really hope that it doesn't rip the threads on the second round, because that would be bad. And now the last step. I'm really nervous. Before I decided to torque down the intake camshaft, I actually wanted to make sure that the valves are not interfering with the pistons, so I've just put on the vibration damper, and there's a marking right there. It's not visible on camera, and marked it up with this pointy thing right there. And I even verified with a screwdriver through the spark plug hole, and piston number 1 is at TDC, and then we can put the cam in with the 2 dots at the back of the cam pointing upwards. The cam couples all get 50 Newton meter. It seems a little bit like not enough, but I guess BMW engineers knew what they were doing. At least I hope so. Now that our top end is back together, we can start working on the VANOS assembly at the front, and then the engine is pretty much done and we can swap it into the car. I've already put the cam lockers on, the crank is at TDC on cylinder 1, so we can start right away with the VANOS installation process. I'm really grateful that there's so much information on these engines out there, because otherwise I wouldn't have known how to rebuild this. Well, there's parts diagrams, but that's always just guessing. But yeah, this goes onto the exhaust side, and it has an arrow right here that must meet flush with the head. As you can see, the arrow right there is pointing exactly at the top of the cylinder head. Now we're going to take our tensioner bypass and screw it in, so that we can start taking out the slack out of the chain. Just screw this flush and then hand tighten the other one, because the BMW spec, if I remember correctly, I've seen a video on it and it's 0.2 Newton meters, so it's pretty much nothing. The guy that had this engine also uninstalled the 2 front plates from the intake side. The first one only goes in one way, like so, and I can still see the outline where it was matching up, so like that. And the 3 bolts for this is these studs that have different sizes of thread. I think it's M7 and M6. These 3 get 20 Newton. The upper guide is held in by 2 e-Torx bolts, E8, and both get 10 Newton meters. The long one goes here and the short one goes there. This is our new upper chain tensioner. It sits like that. And it has 2 medium bolts, 1 long bolt and 1 really short one. The 2 medium ones go from up top, the short one is top behind, and the long one goes all the way through from the front. These 4 bolts also get torqued to 10 Newton meters. Now we're going to install these 3 studs. They go on the exhaust side. M6 part goes outside and the M7 towards the inside. Just like the other 3 studs, these get 20 newtons. Now we have to align this plate with this part and this part. This is splined and keyed, so it only goes in one way. This one also only goes in one way because one end is thicker than the other one and the shorter end goes towards the inside. First we have to align this key with this spline, like so, and then put that in right here, aligning with the other spline. It is a bit tricky, like so. Now we're going to take this sliding rail from our timing kit, this wheel, another piston and another wheel, a new timing chain. Now we're going to position this like that. Now we're going to try to put the chain on and then push this wheel towards the outside so that both sides are equally stretched. And right here it worked first try. Now it makes sense. Both sides are on the same stretch and we can move this, but it's in the same position. Now we have to line up the splines again. The bolts which we're now going to use are these, E8 again. Don't yet tighten these down. We'll have to do the VANOS timing later on. Now we can do the final part of the VANOS timing, which is installing this spacer right there. Then putting this concave plate on, F goes towards the front, like so. And then we have another plate, again with an arrow, that meets up with this arrow pointing towards the head. Just like that. And then 3 10mm. On the intake side we have a relatively flat plate. There's on one side markings from the bolts, and on the other side there's like these lines, and the lines go towards the inside. 3 more 10mm. Up until now we just hand tightened everything because we have to be able to rotate the VANOS cylinders freely. Because now we need to put on the plate right here from the timing kit, and then we need to bring the cylinders into the correct position and torque down the 6 10mm and the 3 e-torques from here. Unfortunately, I still need to find the last 10mm. I just quickly tightened the plate down using 2 bolts, and now we're going to pull out the cylinders so that they're sitting flush with the timing tool on both sides. And then I'm going to untighten the chain. Now that everything is sitting flush, I'm going to start the first round of torquing. I'm going to start with 5 newtons everywhere. Quickly going to verify if the cylinders are still in place, which they are. Also going to start with 5 newtons on the e-torques bolts. Now I'm going to do 10 newton meters for all 10mm bolts. And now 20 newton meters for the 3 e-torques bolts. And that was the VANOS timing procedure. This is our old, stained, disgusting VANOS unit, and I don't want to put this onto this, so we need to refurbish this. To refurbish this VANOS unit, I have an anti-rattle kit and some new Vuitton rings. The old ones are made of Buna, and that material degrades a little bit over 100 degrees C, so not suitable for an engine application. No idea what BMW engineers thought back in the day, but that's what my research told me. And yeah, it's really grimy, really disgusting overall, so I'll just disassemble it, take off the actuators, and then clean it in the ultrasonic cleaner. The side with the 4 bolts is the exhaust side, the one with the 5 bolts is the intake side. The exhaust side has a heavy spring in it, the intake one doesn't. So yeah, when removing the exhaust side you need to apply counter pressure to the spring. This spring is really firm, so there's a lot of pressure. And here we have our VANOS cylinder, like that. Also, these are the rings that we need to change. I will also change the needle bearings inside, which is part of the anti-rattle kit, but I'm just going to chuck these in like that and then do the other parts of the work afterwards. There are no signs of wear inside the cylinder, no scratches I can feel with the nail, so this housing is still ready for use. Now we will be installing the anti-rattle kit on the VANOS cylinders, and then we'll also change the VANOS rings. These are the seals right here. These usually go bad. That's really brutal and it doesn't feel good doing it, but there's no other way. Then you have the cylinder and you can just screw it open. Now that the anti-rattle kits are installed, we need to cut open the rings. There's 2 grooves and 2 rings per groove. You can also try your luck and use a small screwdriver to lever it out. This usually doesn't work, but I'm willing to try. As you can see, these are no longer rubbery and these just feel like plastic. It's not rubbery anymore. As you can see, the second ring is even worse. I can literally snap it almost. You can see, I can just snap it and yeah, then it's done. Not good. These are our new rings. Before we put them on, I'm going to put them in a bag and put them in really hot water. First I'm going to put a bit of oil where I need to slip it over so that it moves freely and I don't tear it, because that would be bad. First, the flexible one. Just roll it over. It moves really easy, you just have to be careful to not tear it. Especially on the second one. For these there's a process called resizing. So you take the matching bore and you put that in at an angle, ideally with some oil on it. Then you can put it in. Also with the bottom one, same story. And now I'm going to do the same one for the second one. Now I just need to install the VANOS unit onto the head, and then the engine's pretty much done. The oil filter housing, we're just going to install that once the engine is in the car, because on both the intake and exhaust side I want to have as much space as possible to do the swap. A new gasket. This is our rear main seal, and now I'm going to knock the old one out using a screwdriver and a hammer. That went actually really easy. I'm really surprised. This went a lot better than expected. This is now ready to go back onto the engine. I'm going to apply a bit of gasket maker so that it seals. So this engine is now officially ready to go back into my E46, and I'll gladly do so in the next episode. Unfortunately, I'm a bit behind on my schedule, so this will have to do. Thanks for watching and see you in the next one.